A consensus algorithm is needed in any distributed system, and they have three key performance metrics. Security, as permissionless blockchains must be resistant to a certain level of adversary attack. Throughput, measured in transactions per second. And confirmation latency, the time for a transaction to be finalized. Bitcoin was a breakthrough in building distributed trust systems. It has excellent security, resistant up to a 50% adversary. However, throughput is below 10 transactions per second, and confirmation latency can be over an hour. Bitcoin's throughput of a 1 megabyte block every 10 minutes equates to 15 kilobits per second, supportable even by internet infrastructure in 1994. Today's networks are over 1,000 times faster, but blockchains are not yet exploiting this. Bitcoin's throughput and latency are controlled by the mining rate parameter, set at 1 new block every 10 minutes. Performance could be improved by increasing the mining rate. However, this increases forking of the blockchain due to communication delays between miners. This forking decreases the security of the blockchain. Because of this, Bitcoin suffers a fundamental trade-off between performance and security. Many proposals have emerged to improve on this longest chain protocol, for example Ghost, Phantom and Conflux. But they all open up new vulnerabilities, or their claimed properties are not mathematically proven. Prism is a breakthrough which matches the excellent security properties of Bitcoin, resistant up to a 50% adversary, while achieving transaction throughput close to the bandwidth limit of the underlying physical network, and confirmation latency on the order of the speed of light propagation delay. All these properties have been mathematically proven. Therefore, Prism operates near our physical network limits, without a trade-off between performance and security. Consensus algorithms require two actions. New transactions must be proposed to be included in the blockchain, and participants must then vote on which proposed transactions are confirmed valid. In Bitcoin, each block performs both actions. New blocks contain transactions which are being proposed for inclusion in the blockchain, and new blocks also implicitly vote for all the transactions contained in their parent blocks above. The classic Bitcoin client waits for a transaction to be 6 blocks deep before marking it as confirmed to provide security against private double-spend attacks. Implicitly, 5 votes are needed to confirm a transaction, and the slow voting rate is the reason why the confirmation latency is so long. Instead, Prism makes the proposing and voting roles explicit by deconstructing the blockchain into proposer blocks and a voting blockchain. Proposer blocks reference transactions to include in the ledger. Voter blocks vote on proposer blocks. With this deconstruction, we can run many parallel voter blockchains to fully utilize the network bandwidth. If, for example, we have 1,000 voter chains, the total voter block production is increased 1,000 times, while the mining rate for each individual chain is unchanged, preventing forking and maintaining security. This significantly increases the overall voting rate, leading to very fast transaction confirmations. To provide security, it is important that miners do not know in advance if their new block will be a proposer or a voter. Therefore, new blocks must contain both the proposer and the voter metadata. A random sortition procedure using the hash function then determines the post-mining role of each new block. This means that every voter block also contains a set of transactions. Each proposer block can refer to all the transactions contained in voter blocks across the previous level. This scales up the number of proposed transactions at each level by the number of voting chains, optimizing the transaction per second throughput. For more information, check out the research paper Deconstructing the Blockchain to Approach Physical Limits, where Prism has initially been formulated in a proof-of-work setting. A proof-of-stake design of Prism will be the topic of a forthcoming paper.